Hi guys, welcome back to my channel, and today we'll be learning how to solve a 2x2x3 cuboid. So let me quickly introduce you to it. First of all, don't let the shape intimidate you. While a standard 3x3 has 43 quintillion possible combinations, this cuboid has only 29,160 possible positions. Secondly, look how this cuboid is built. On a normal cube, the middle layer spins freely, but here the middle layer is structurally locked to the internal core. So instead of fighting three independent layers, we are essentially going to work on sandwich where the top and the bottom are the bread and the middle would just fall into the place. And finally, for the 3x3 cubers out there, forget everything you know about OLL and PLL. Because in this cuboid, the side faces can only do 180-degree turns. So pieces can never physically flip or twist upside down. So there is no orientation step at all. So every single piece is always facing the right way, and that means we would only be swapping the positions. So let me introduce you to the notations real quick. So there is U, which is top layer clockwise, and then there is U prime, which is top layer anti-clockwise. There is R, which means 180-degree flip on the right side. R prime would literally mean the same because it is 180-degree flip. And there is F, which is like this. And F prime would literally mean the same because it is 180-degree flip as well. So now let's begin the tutorial. I'll quickly scramble the cube. Let's begin solving this. So in the first step, we would solve the top and bottom layer together. And in the next step, we would solve the middle layer. So as you can see, white and yellow are the two colors that face at the top and at the bottom like this. So what we would want is all yellow pieces to be on either the top and bottom layer and at the correct position. And on the opposite side, we would want all pieces to be white and at the correct position. So now let's look at the different possible positions for white and yellow pieces on the top and bottom layer, and let's learn how to solve them. Case 1 is where we would get continuous bar on top as well as bottom layer, but they are of different colors. So what we want is all yellow on one side and white on the other side. In order to do that, let's just flip this so that this yellow is aligned with this white here. And we could make an F move so that all yellow and white pieces are on the same side. Case 2 is where we have three pieces of the same color and one of different. So here we have three yellow, one white, and on the opposite end we have three white and one yellow. So in order to solve this, look at this where there is no continuous edge form. So yellow is on the top, white is at the bottom. So on the opposite side, we would need the same configuration where yellow is on the top, white is on the bottom over here. So if I just rotate this, we get like this, yellow on the top, white on the bottom, and then I can make 180-degree flip. So we have a continuous edge formed here. And this becomes the previous case where we would just rotate this and make an 80-degree flip so that all white and all yellow is on the same side. Case 3 is where we have bar on one layer and there is a cross pattern at the bottom layer. So in that case, we could make our move so that this becomes case 2 where three pieces are of same color and one of the other. So here again, we have yellow on the top, white at the bottom. So we could just flip this so that we have yellow on top, white at bottom, again making 180-degree move so that we get continuous bars and again like this so that we have all yellow, all white. Case 4 is where we have cross on both the layers. So in that case, if one layer has yellow like this, white like this, on the other hand, we would want the opposite. So we have here white like this, yellow like this. Then we could make an R move so that we get continuous bars on both the layers. And if I just do this, this becomes case 1. And accordingly, I can make an R move to get all white and all yellow on the same side. So ta-da, we are done with placing all yellow and all white pieces on the same side, and now we just need to worry about their positions. So for putting the pieces on the top layer at the correct position, let's look at some cases. Case 1 would be that a continuous bar of any color is formed on the top layer. So to apply the algorithm, keep that bar on the left and then apply the algorithm which goes like R, U, R, U prime, R, F, U prime, F, U, F. And then we can see continuous bar for all the colors have been formed. Case 2 can be that there are no continuous bars on the top layer. So in that case, we would need to apply the algorithm twice. And so you can just pretend that there is a bar on the left and I can just apply the algorithm. Then, and after once you can see that that would be a bar formed. And that formed bar should be kept on the left and we could apply the algorithm second time. And after 2 times, all 4 continuous bars would be formed. So after finishing it for one of the layers, you could apply the same thing on the opposite layer. So let's do it for the yellow side. So here we can see that there is one bar over here. So we would keep it on the left and then we could just apply the algorithm just one more time and we can see that all 4 continuous bars are formed. And ta-da, we are done with the top and bottom layer. So now let's begin solving the middle layer. So before solving the middle layer, try to align the top and bottom layer as much as possible. So I can just rotate this twice so that green, orange, blue and red match. And as per the middle layer, try to align this layer as well as much as possible. So this piece contains red and green, so I have aligned it with red and green intersection and similarly with the other pieces. So now to properly orient the pieces of the middle layer, you can apply the following algorithm, which would actually swap this piece over here and this piece over here on the right hand side. So this would actually twist and turn and come here, and this piece would actually twist and turn and come here as well. So the algorithm is pretty easy to remember. So it goes R, U2, R, U2 and R, U2. So you can see that the piece which was over here came here and this one swapped here. Now based on that, we could just rotate the middle layer and we can see that this falls to its correct position and orientation, and accordingly we could apply the same algorithm to this and this piece as well. So looking at this, we can see that this piece needs to go over here. So we can apply the algorithm and just swap this and this piece. So quickly apply the algorithm and you can see this piece is now to its correct position from here. And the last part, again, these two need to be swapped. So we can just apply the same algorithm again. And ta-da, we are done with the cuboid. Now, another scenario can be like this, where you can see there are continuous bars formed on the middle layer, but you have 2 pairs and they need to be swapped. So this and this piece needs to be solved and this piece needs to be swapped. So what you could do is apply the same method that I taught previously for these 2 pieces once and then the next time for these 2 pieces. But there is a shortcut which you can apply, which goes like R and then middle layer twice and again R, and now you are done and you just need to orient this. So this is a shortcut that you can remember. So third scenario you can face is like this, where exactly one piece in the middle layer is at its correct position and orientation, but the rest 3 aren't. So regular algorithms you would apply twice for swapping this pair once and then this pair. But another thing you could do is just find the piece which is at its correct position. So this one has red over here. So on the opposite end we have red here as well. So if I make an arm move, this makes a continuous edge over here. I could rotate this and you can see this one has green over here and this one has green over here on the opposite end. And again, if I do this, then this jumps to scenario 2, where 2 pairs need to be swapped. So we can see that this pair needs to be swapped and then this pair needs to be swapped. So I could apply the previous algorithm twice, again this and this twice, and now we are done with the cuboid. So that's it guys. I hope the top, bottom, middle strategy made total sense to you. Also don't forget to hit the like button and subscribe to my channel.
The neon signs light up the